Okay, so let's go ahead with a walkthrough of some of the enhancements in 4.0. The key themes with this new release is around performance, is around the use of Intel Optane, consistency, and security. So when it comes to performance, some of the new capabilities in 4.0 were optimizations that are put in to give you greater throughput and lower latency in a lot of the operations in Hazelcast IMDG. One enhancement was reducing the number of network hops when acknowledging backups. So this does not change any safety guarantees. So you do have all of your backups available for high availability purposes. And this feature is enabled by default, and we've seen up to 30% performance improvement by minimizing the network hops as part of that backup process. And then we're including data in motion performance improvements when using OpenSSL. So it's always our recommendation to use data in motion encryption to make sure that you have privacy across all of the different components within your Hazelcast deployment. And in this case, if you have OpenSSL installed on your systems, Hazelcast will use that by default and give you up to 200% performance improvement there. And then there are a number of low-level back-end serialization performance improvements that will further improve the overall system. And the last point I want to make is that there are no compromises on the data safety in terms of gaining performance. So a lot of times in other technologies, performance gains might be done by taking shortcuts in other areas. So necessarily making a trade-off somewhere else for the sake of making the system run faster. And at Hazelcast, we do not make those trade-offs that might jeopardize your system in other ways. For example, one way that you can improve performance is simply by reducing the number of backups, whether the count or turning them off entirely when you're seeing a high load. And we've seen other technologies do that. And when you do that, of course, you're adding more risk in terms of potential for data loss, because if you have fewer backups, if you're not updating the backups at all, and there's a failure in your system, then you could lose data and get into a situation where you'll spend a lot of time troubleshooting and resolving that. And so one of our core principles is make sure that if we're improving performance, it's doing it the right way without jeopardizing your system in terms of reliability and other guarantees that you would expect as part of a production system. So next I want to talk about our Intel Optane support, especially when it comes to HD memory. So you might have seen an announcement earlier this year where we were certified for use with Optane as a persistent store as part of our hot restart capability. And so if you look at the chart at the bottom, you'll see a graph that shows the more threads that you have, the faster the restart time using our hot restart store when you use Intel Optane versus SSD. Now let's be clear, there are actually two modes for Intel Optane depending on how your software leverages it. So in this previous use of Intel Optane as a hot restart store, we were using it in persistent mode. And so while the technology is called Intel Optane DC persistent memory, that certainly makes sense in that context. But the fact is you can also use Intel Optane as a volatile alternative, a volatile memory alternative to dynamic RAM. And so that's what this new addition to 4.0 is about. It's about using Intel Optane as a nearly as fast as RAM alternative, but a much cheaper, a much more denser and higher capacity alternative. And so with the HT certification on Optane, that simply means that we can take data off heap and thus grow your pool of RAM across your node much bigger than you would if you used the Java heap. So you get this support with minimum configuration, no code changes, and data structures like IMAP and iCache, and features like near cache can use Optane as that in-memory storage layer for off-heap HD memory. And as I mentioned, this complements the hot restart store and represents just another way that you can use Optane as part of your in-memory deployment. So let's talk about consistency. So some of you might be familiar with our CP subsystem, which allowed strong consistency as part of a deployment. So if you're familiar with the CAP theorem that says that in a distributed system, you can have two of the three guarantees when it comes to partition tolerance, consistency, and availability. And you might know that most distributed systems today are AP, meaning they provide availability and partition tolerance, but don't guarantee strong consistency. And with the CP subsystem introduced in IMDG 3.12, now you have an alternative model where you can ensure strong consistency with partition tolerance with some relaxing of the availability. And so this was, as I mentioned, was introduced in 3.12, and turns out that some people wanted to use the CP system in ways that wouldn't necessarily guarantee strong consistency. And one example is that with the CP subsystem, to get all the guarantees, you would have to run at least 3 nodes for quorum purposes should you have a network partition. And so with this new feature called unsafe mode, you can now run the CP subsystem with fewer than 3 nodes. So 1 or 2 node clusters can support the data structures in the CP subsystem, whereas in 3.12, you simply could not do that. And so one of the main use cases of being able to support the CP subsystem in 1 or 2 nodes is being able to test your code. So if you write code that involves strong consistency and you want to test it, you don't have to stand up a 3-node cluster. You can run it on a single node, or you can run it on a 2-node cluster as well. And of course, if you're running it on 1 or 2 nodes, just be very careful and realize that you're not going to get the strong consistency guarantees. And never mind the data safety guarantees of running an implementation in only 1 or 2 nodes. And so there were some data structures that were deprecated in 3.12, and the CP subsystem in unsafe mode allows you to essentially run the same type of functionality, again, in an environment that's not guaranteeing data safety or strong consistency, but again, that is available to you. And now let's talk about another component, new component in the CP subsystem, which is persistence. And this is in the Enterprise Edition only. And this is a mechanism that allows you to persist the local state of your CP subsystem nodes to non-volatile storage, so to an SSD or even to Octane if you'd like. And this is about improving reliability and of your entire system by persisting that data so that you can have fast recovery without any sacrificing any safety guarantees. And with a lot of the strong consistency work that we're doing, we're always running the fairly well-renowned Jepsen testing framework. And if you're not familiar with Jepsen, you can look it up. I believe the URL is jepsen.io. It's a test that was put together to test distributed systems and see how well they withstand failures within the cluster and how well they maintain data durability. And so we ran this on our CP subsystem. Previously, we run it with the persistence mode on, and so we can guarantee that that data will be durable, that you get the strong consistency in any type of use case where it's important to have a consistent state of data across the entire cluster. Now let's talk about new security enhancements, and one is the encryption at rest for the hot restart store. And again, this is with the Enterprise Edition only. And so now all entries stored in the hot restart store are encrypted using symmetric encryption based on the Java cryptography architecture. And the master key is used to encrypt these store-specific keys, and you can use an external system like HashiCorp Vault. It also supports master key rotation without shutting down your cluster with no performance degradation. And of course, if there's a failure and you need to handle re-encryption, then it gracefully handles that. And let's talk about security from an authentication standpoint. And new in 4.0 is out-of-the-box LDAP integration for Enterprise Edition only. And so there are two new Jazz login modules to authenticate against your LDAP server. And previously you had to write your own LDAP login modules, and now we're offering that out of the box. So it'll simplify the integration with your existing LDAP servers when you're standing up new Hazelcast clusters. And so just to review the range of security features as part of a Hazelcast deployment, you'll see on the left there are the various clients. So you might have applications built on IMDG talking to an IMDG cluster, or you might have a browser that you use to talk to Management Center. And so as you move right, you'll have private connections to IMDG or to Management Center using TLS. And then you'll see in the middle, in the upper middle, authentication with Jazz. We also have the socket interceptor, which you might remember is essentially a hook that allows you to write custom code for authentication. So it gives a lot of flexibility in the types of authentication you want to do. And then there's the authorization with Jazz authorization. And then comparable to the socket interceptor, there's a security interceptor. Again, another API that allows you to plug into the authorization process and write your own custom authorization modules. And then as I mentioned earlier, TLS for encrypting data in motion ensures that any communications between clients, between members, between Management Center is protected. So a level of security that many environments require today, especially with the sensitive data that's being used in Hazelcast. And let's talk about some other enhancements. And just to quickly go over some of these, MapLoader now supports custom time to live specifications. And so if you're using IMDG to read from a system of record and want to be able to specify when that data that's being cached gets evicted, then you can specify that custom TTL parameter during the loading process. So it gives a little bit of more flexibility in terms of how you manage data that gets stored in a cache type of environment. And then JSON support for REST. With the REST interfaces, you can now read the JSON format that's stored in IMDG and included as part of that REST output. And the final enhancement I want to mention is the new naming mechanism for Hazelcast instances. And so you might remember with some of the auto-generated naming, the names look very familiar and so can be very confusing, especially when you're doing some troubleshooting. And so if you're familiar with the Moby project, which is an open framework built by Docker for being able to create specialized container environments, they have a naming generator or name generator that we've leveraged. And so you can now have Hazelcast instances with names like Hopeful Turing and Brave Driscoll. So very creative, very unique names that help simplify the process in troubleshooting and identifying the different instances. Thank you, everyone, for listening to this webinar. I hope you enjoyed it. Be sure to check out hazelcast.com for any additional announcements on coming up in the next few months, as well as any webinars that we have planned. And hope to see you next time. Thanks a lot.